Hello, Honors Chemistry, and welcome to your welcome demos, because I don't know how all this is going to work, so we're just going to do them this way, all right? So welcome and enjoy as we look at some of the things we'll learn about this year. So here we have 3 clear, colorless liquids, and we are taking some plain old paper and putting it into each of these beakers of 3 clear, colorless liquids. And you'll note that there is a candle to provide a flame. And then now we're going to take that paper from that first beaker and we're going to expose it to the flame. And what do we observe? Nothing. Nothing is the answer. Nothing happens to the paper, right? So what can we say? Now we take the paper from beaker number 2 and we subject it to the flame, and lo, it is definitely on fire. You'll see that clearly there is fire before the paper catches fire, right? And what does that tell us? And now we're going to take the paper from C and subject it to the flame, and clearly catches fire, but the paper does not burn. Oh my goodness, this is a property of mixtures. Yes, wherein mixtures have the property of all the things they're composed of, which is a little bit of liquid A and a little bit of liquid B. Here we have 2 100 ml approximately samples of water. They're a little bit bubbly because no one's used my water all summer, and so it just gets that way. And I've added a pH indicator, and they're both approximately pH 7. Green is about pH 7, so one beaker is a little bit lower in pH than the other, but they're similar, right? So now what we're going to do is we're going to take these 2 beakers of water, and to each beaker we're going to add different chemicals, right? And we will observe what happens. Sodium bicarbonate, also known as baking soda, is going to go first. We'll note that there is an immediate color change. And then we are going to put some calcium carbonate, commonly known as marble chips, into the beaker on the right. And what do we observe? All right, so swirl, 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 and then stir, stir, stir. And then what's important to take note of, right, is that on the one side, we don't see a lot of powder residue. On the other side, we can still clearly see giant marble chips sitting down there, but they both end up blue. We'll learn to predict solubilities in Chapter 7. Red solution is acetic acid, aka vinegar, which is red because it's an acid, and that's that sodium bicarbonate solution. And now we are going to take that baking soda solution and add it to the acetic acid, aka vinegar solution, and lo and behold, bubbles. Lots of bubbles. And bubbles, and bubbles, and bubbles. By the end of Chapter 7, you'll be able to predict what's reacting with what type of reaction it's undergoing, what it's producing. You'll be able to balance it. And in Chapter 8, you will be able to write the math for the mass of bubbles produced or the number of molecules of bubble produced. By the end of Chapter 14, you'll be able to discuss the pH, right? Why does that acetic acid go from pink to less and less acidic as time goes on? In addition, using your Chapter 8 skills and your acid-base skills, you'll be able to talk about how much baking soda is necessary to neutralize all of that acid, and what we'd be looking for to know that the neutralization reaction is over, right? All right. This is a fun unit. If we have time, we like to do a little bit of organic chemistry, if that allows. Here we have 40-ish mils of water, which we are going to pour into this cup, slowly but surely. And then we have to get a little bit more water because what I got was not quite enough to do the job. Behold, we've added like 100 mils of water, and then we go and no water comes out. Oh my goodness. And instead, we get lump of goo. That lump of goo is known as sodium polyacrylate, which is a neat polymer that absorbs water. And I'm sure if you put your mind to it, you can come up with lots of applications for water-absorbing polymers in our everyday lives. Last demonstration about gas laws. So we have a can sitting on a hot plate. Inside that can is a tiny, tiny bit of water. And this is just showing you that it is indeed heating, right? So 460 is just the final temp of that hot plate when it gets there. And we have a little bucket of ice water, right? And this is our setup. Currently that can is being heated and we are gonna wait while that can heats. And now that can is quite hot. So hot, in fact, that we can see wisps of smoke, steam coming out. If we listen carefully, we can hear the sound of the tiny bit of water, and they're definitely boiling. And now we are going to use some tongs because obviously the can's hot. So we're going to use some tongs, grab that can, and flip it upside down into the water. What we do is we are creating a vacuum inside the can, and the pressure of the atmosphere literally crushes the can. Like the force of it squeezes the can. How cool is that, right? Stuff that we'll do second semester. In fun is obviously more person than this way, but slow-mo, that's a perk, right? Anyway, thank you for listening. Be good, and I will see you soon. Bye.